Hi, this is Template Podcast, where we discuss embedded Linux, IoT development, and anything else we might find interesting. And your hosts are Kim Raj and Cliff Break. Today, we have Thomas Petazzoni.
Hey.
Hi, Thomas. How are you doing?
Good, thank you.
We are really excited to talk to you today. And Thomas, as you know, is a longtime Buildroot contributor and maintainer. And he works for Bootlin, which is a well-known company in open source, especially in Linux space. And he's CTO for Bootlin. So today we'll know more about Thomas and also learn from his experiences. So I think, Cliff, it's going to be fun. What's your take on how the open source started and, what Thomas brings to table? I think I'm really excited today.
Yes, certainly.
Cool. So Thomas, I think, it will be good to kind of, if you discuss a little bit about your background or what you what the path that brought you here. You started working on, embedded Linux or in software. And what was that? So it will be good to recount on that.
Yeah. So I think it's a fun and interesting story, maybe a bit long, but it's kind of interesting, especially if you compare it to how young people today have access to technology. So I like to get back a little bit to that. So back I'm born in 83. So right now I'm 37, just to give some ideas. So I was basically around 10 years old in the early 90s. And back then, due to some activities my dad had, he was not at all working on computer science or anything like that. But he got access to a computer, which everything starts there. And that was a Intel 286 machine that we got at home, a laptop. Well, calling it a laptop, you could do that back in the days. Nowadays, you wouldn't call that a laptop anymore. But anyway, we had that thing. And so it was early 90s, 92, 93, 94, something like that. I was 9, 10 years old. No internet access, no web, obviously. And so we had this machine, it had DOS and some oldish version of Windows. So you explore it, you play games. There are just 3 games. You look at things, you explore the system a bit, you tinker with it, but you're pretty limited. You read the documentation that comes with it, but yeah, pretty quickly you feel a bit limited. And by exploring all the comments that were on the system, I found one called QBasic. And that kind of caught my eye, but no internet, no nothing. So I went, and I remember my parents brought me to the bookstore of the village where I lived, and I asked the man taking care of the bookstore, and okay, do you have books about that thing? So we looked up on this thing we had in France called the Minitel. It was the thing we had before internet. You could connect to online services through some text mode thing. So he searched some books for me and actually ordered one. So I got a book about BASIC, but nobody around me knew anything about programming, right? I was really on my own with that book, my BASIC interpreter on this machine, and really discovering things. And there were also magazines in France. There was a science magazine with lots of articles about science in general. And every month they would publish a listing in BASIC of a program that you had to type yourself again. You would, of course, make tons of mistakes by copying again the program, which were really interesting. And then it would draw stupid things on your screen. And that's how I got into this programming really on my own. I think that's really something that is different compared to today, where everybody has tons of videos on YouTube, as much documents as they want. I was really on my own, doing all this research, experimentation, tinkering. And the fact that I was alone kind of forces into digging by yourself and puts into your way of tracking bugs, investigating things, this methodology that perhaps some of the younger generation have more difficult to grasp. But after a few years, not much, I got the chance to finally meet someone working in the computer science industry. And he told me, BASIC, no, give up on that.
Yeah.
Here is the Kernighan and Ritchie book for you, and you're going to learn C. Back then, I was in, how would you call that? Is it secondary school or junior high school or middle school?
High school.
Not, sure.
Yeah.
Not yet high school, because high school
middle
is
school.
When you're 15 plus or something like that. So it was before that. So I had this book that allowed to learn C, the Kenigan and Ritchie, in maybe a little bit the hard way. And it was also at this time that I started to get access to internet, which really changed things completely for me. Because you had access to newsgroup. So I read the newsgroup about the C language. And that's where I met another like young guy like my age, really same grade, from a completely different place in France. And we started discussing. And I think one thing we were lacking is like a goal, a purpose. Like, okay, you learn programming, but to do what? And indeed, many people, they want to program a game or something like that. But I'm not sure how we came up with that. But we said, okay, we're going to write an operating system. And I was like 14 or something, or 15 or something like that. It was completely stupid. Back then, I didn't even know what malloc was for, or what, that kind of things. So it was totally crazy. But I'm not sure exactly why and how, but we really did it. And it's still online today. There is a website. You can browse it. There's the code is available on CBS.
Nice.
And so we really, we learned, we bought like the Tannenbaum book, read it like 10 times. And we had no computer science education. I was still in high school at the time. And so we learned assembly, started writing, these small assembly steps to boot your x86 machine. And then we learned how to write the early steps of C, and had to learn the MMU and all the interrupt tables and all that kind of things as we go. And thanks to the newsgroups, I got connected really early on to engineers or even people with more experience. And way before I started university, I was taught by those folks how to write C, how to debug code, how an operating system is working. So at the time, I was still running Windows. I was doing all my development from Windows. I had heard about this Linux thing. I had bought maybe, a Slackware distribution, tried it, but it was still a bit difficult there. But I had already started writing this small operating system. So pretty early on, my kind of path towards low-level stuff and not embedded systems, but like system-level stuff was already written. And pretty much everything that followed that path. I continued working on that operating system called KOS, for Kid Operating System, because we were kids. And and as I said, it's still online for a couple of years. And what I also did when I entered university with one of the guys who contributed to this project and has been a key person for me, who taught me a lot of things way before I had access to computer science education. We restarted the project, we did a slightly different operating system, but this time with a strong educational goal. And what we did is that for every step of writing the operating system, we were writing a very lengthy article that was published in the Linux magazine in France. So I think we published like 12 or 13 or 14 articles, each of like 10, 15 pages long. So pretty much almost a book in the end, really describing like, okay, here we're booting, now we're setting up the MMU, what it means, how do you do that, what is virtual memory, and all these things with lots of diagrams and so on. And that's what I wrote throughout my university time. So of course, university for me, the computer science level was not extremely exciting. Of course, there were more topics that I hadn't touched a lot, but for lots of like C programming and system stuff, it was all pretty much relatively well understood, I would say. So yeah, really, I think this path is I find it interesting when you compare to nowadays access to technology, is really the fact that I was alone facing this machine that I wanted to explore what it could do. And the fact of being limited with just a book in this machine and just struggling, trying, testing, experimenting, tinkering, really got me to dive deeper and deeper into all these different topics. So I don't know how many hours I spent into that. I remember my dad going into the basement, turning off the electricity of the house to bring me to dinner and stuff like that. So funny times. So anyway, I was in university, and at the university I was in France, we had 2 internships. In my first internship, I worked on an embedded operating system, was closed source at the time, but still it was a really great experience. And also through that, those two projects, the persons that I met were really strong open source free software people. So my cousin that I ended up, in fact, meeting through that project, I had barely a relationship with him before that. But thanks to that project, I kind of met again a person from my family who was a lot into computer science. And he ended up working at Docker later on. So he's still very much in the field. He told me, yeah, you need to use Linux, and I'm going to show you how to use Linux. So he taught me like CBS and the shell and all these kind of things. And so this also not only taught me C and system level programming, but introduced me to the open source world, both from a technical level, but also more from a ethical level, where this concept of sharing, which, as I said, this series of articles that we published was very much about sharing knowledge. So that's something I got pretty early on as well. And so for my final internship, I worked on Linux. That was my first real professional experience with Linux. Of course, I worked on it at university and looked at the source code a lot. But my final internship was about porting Linux to a MIPS platform. So I really entered the kernel development for real at this time. And it is also the time where I did my first contribution to Buildroot, which is another key thing in my in the rest of what I did as a hobby and at work. So really, yeah, these different elements combined kind of led me to doing open source and Buildroot. And so when I was at university, I was also a very strong free software advocate, organizing install parties and talks and workshops and teaching people about using Linux. And I remember it was like my university times were from 2000 to 2005. And back then, when you were doing Linux, you were a little bit the crazy penguin guy, right? It was still like that. And I very much remember people like making fun of those like Linux geeks, this thing that is free and that will never be useful in business and stuff like that.
Sure.
And meeting them years later at Linux conferences, Linux trade shows and stuff like that, like advertising products based on Linux. And so it was very
interesting times.
Yeah, interesting times.
Yeah, so I think that's a very interesting story, really fantastic. And all the steps kind of like you learned through, I find it very interesting that was your, gaining the experience, like filling yourself up with a lot of knowledge. And I think that's very important for anyone, right? That even modern times you have all the devices, but in order for someone to fit into a particular area, they have to start learning and they have to kind of have that knowledge, even though it is readily available, but grasping that is still on you or, on the person. So very informative to know that, that process is actually what is behind it. So
I think you really need a purpose, like something you want to achieve. And these days, even myself, I find it more difficult, a well-defined purpose that I stick to, perhaps because, and I in part blame it to the luxury of information we have access to, right? We have so much information available, so many goals that we can try to achieve, that in the end we are, at least this is something I feel personally, we are less focused, and it's a bit more difficult to really like, this is what I want to achieve, and dig and dive and spend the time doing things. We're more like jumping there and there, doing a bit of this, doing a bit of that. I find it more difficult to stay focused in these times of like mass of information.
Yeah, information overload.
Yeah.
So why is open source important to you? I know that you touched that, that you were passionate from beginning about sharing. But I think open source means a lot more than that nowadays. Like people have companies based off of open source, right? And of course, like open source is not only limited to software anymore, right? It's getting into hardware, it's getting into like legal processes, government. So, it has become more like a way of doing things, right? So, but I hear you say that, it was very important to you from very beginning. And so what does it mean to you, and how important it is to you?
So I had different periods in my life in terms of open source involvement, right? I was initially, as I said, I came from a really technical background and got like acquainted with this idea of knowledge sharing by meeting those people who were teaching me things. And so I really early on wanted to also like share things again. And so it became pretty natural when I discovered open source, Linux. Again, I discovered it as a technical thing before being more a social, political object, if we can call it that way. Mm-hmm. But definitely at my university time, I met more people who also discovered it in the same way as a technical thing. And then usually I think when you're in university or late years of high school, that's where you're like political opinions or your reflection about the society and politics. Maybe it's not so advanced, but it's the moment where you start asking questions about how the world is working and politics and in all sense of it, both like elections and politicians and so on, but also like true politics, how society is working, is organized, and so yeah, my interest for free software as a technical thing naturally expanded as an interest free software as a political thing. So at university we did a lot of, as I said, free software advocacy, not just on the technical aspects, but also a lot on the ethical aspect, like information sharing, knowledge sharing, transparency. It was really the time of this battle between free software and Microsoft, and which today is a little bit like, kind of interesting if you look back. But back in the days, it was still this like very strong opposition between proprietary software, Microsoft, and free software, which is still like something really at its early stage, at least in the business sense of it. And so that's how it grew, and really. I met a lot of people who liked free software as a political thing, so it helped me think about that. And so we, as I said, organized install parties internally at the university, but also locally around the university, trying to spread the word to non-technical people. And even when I moved here, Toulouse, southwest of France, I set up the local Linux user group, organized install parties, conferences, and trying again to like touch a lot of non-technical people, and it worked. So I had this pretty long period of time where I was mainly focused on advocacy. At work, I was doing technical stuff, but really my spare time was more oriented toward advocacy. Mm-hmm. And gradually, I turned back to more technical things. So nowadays, I'm no longer really involved in advocacy. I was to share how much I was involved in advocacy. I was in the boards of the main organization in France for free software advocacy. It's called April. It's pretty much the FSF, but in France, if you want. So this organization had that connection with the FSF, and really people who fight for free software and software freedom, open formats, fight against software patents and stuff like that. So I was part of that organization as a board member. So I was really deeply involved. I think pretty much like in everything I do, I very often go pretty
towards the deep end.
Yeah, it was until the end. And at some point I felt, okay, I did what I could. And my interest kind of moved back to more the contribution aspect. And it's the other thing that really drives me a lot in the open source. It's this rewarding feeling that contribution gives you. It's completely independent from the political aspect, I find. Yeah. It's really this thing that you do something and you get some feedback from people showing that it is useful. And I get this feeling a lot due to my contribution to Buildroot. It's a project I've worked on since 2008. So I've seen that project change and grow, and I participate to that change and growth. And it's, of course, very rewarding to see it gaining in popularity, gaining in number of users, gaining in contributions. and it keeps you moving.
That's very interesting, Thomas. Could you describe your involvement in the Buildroot project? We'd like to learn a little more about what you do there and just how that project works.
Okay, so maybe just a brief recap on what Buildroot is for the people who are going to listen to us. It's a tool that automates the process of building a Linux system from source. So it compiles all the components of the software components that will make up a complete Linux system. It can be as simple as just a Linux kernel, a C library, and BusyBox, but you can also add up tons of libraries for graphics, for networking, for crypto, for lots of different things, multimedia stuff, and so on. And it is really widely used to build embedded Linux system because it's simple. You can optimize and customize things as you see fit. So that's like in a few words what Buildroot is. And I think for open source projects, the journey is almost always a little bit the same, right? You start as a user, you need something, you discover a project, you start using it, which is what I did back in my final internship. I needed something to build my MIPS system and a tool chain. So yeah, Buildroot was one of the things that was there. It was not really very popular back then, but it was one of the few tools that existed. So I tried it. It, of course, didn't work completely for me. So I started tinkering and trying to debug things. And I ended up like becoming a small contributor. That's usually how things go, right? You're a user, but facing some limitations or bugs, you investigate them. And if you have this open source mindset, you don't want to keep those changes for you. You want to share them with others. Not just, I think there's this, people think of it like I'm giving to others, but you're also receiving back, right? Because you're receiving back the review that will help you like understand better how things are working. So it helps increase your own knowledge. So I started contributing that. I think that's the second step of being the journey in open source, right? You switch from being just a mere user to just an occasional contributor, just sending a few things that you've tried that has improved things for you in a way or another. And back then, in addition to the fixes, I did something that a lot of people I think can do as users is I wrote the documentation for the project. So it was kind of my key thing that I wrote back then. It was not complete, but it was at least like what I wish I had seen to get me started with Buildroot. So it's a neat way, I think, to really jump into it. And then I had this parenthesis for a few years where I worked in a company doing Linux stuff, but it was closed source and it was no longer embedded. So I was doing kernel stuff, still system level, but no longer embedded, no longer really connected to open source, so not much work. And in 2008, I got hired by the Free Electrons founder. A company was called Free Electrons back then. I was the first employee. And because of what we do, embedded Linux, I moved again to Buildroot and started contributing more and more. Again, because we were using it for our own trainings, for our experiments, finding issues, things to improve. And it's like, it's a never-ending like snowball, right? You find like a small thing, but when you solve it, you realize, oh, we could improve this and that and that and that. And then when you solve those things, you discover more things around that you could solve one more and more. And then the snowball is so huge that your to-do list is like filling up much quicker than you can empty it. So there's this really rewarding effect of doing things, seeing that people use it, give feedback that it is useful for them, that it fixes issues for them. Gives you more idea as well to extend the size of that snowball, and then keeps you moving and moving and moving. So I did contribute to Buildroot gradually more and more over the years due to both professional input, but also a lot of that community input that, as I just explained, really drives you into like doing more and wanting to do more, wanting to fix up things more, wanting to clean up things more, to refactorize the code and so on and so forth. And over time became one of the co-maintainer of the project, which I still am. So that's kind of the journey I took. But again, it's as you can see, kind of the journey started in 2004. We are in 2020 now, so it's been like 16 years that I initially started playing with Buildroot. So it's not something that happens overnight. I sometimes see all those people asking, I want to learn kernel development, but they're only ready to spend like a week or two doing that. Yeah, it's not going to work, right? It's really a long-term thing that allows you to get into a position where you can contribute significantly to an open source project. So that's pretty much my journey. And today my work as a maintainer, or one of the co-maintainers, we are four maintainers in Buildroot. So we don't work like Linux where we divide the project into subsystems. It's really like 4 maintainers that can all touch any part of the system. So we have sufficient like trust and interaction and communication that we don't step on each other's toes. We know who is going to work on something, or that doesn't. So far, it's been working really, really well. So as a maintainer, I review patches submitted by contributors, give feedback, merge it, and I work mainly on tooling for the maintenance of the project. That's kind of my key thing in the past few years, things like automated testing, notification to developers when something is broken, all this tooling that helps maintaining a project like Buildroot.
Mm-hmm. Yeah, that's fascinating. What would you say some of the core values of the Buildroot project are, like things you hold really important as a project?
So I think one of the core value is simplicity. One of the competitors, I think it was in our outline for this discussion, is Open Embedded and Yocto, which falls on a different part of the scale from a complexity point of view. So one of the focus is simplicity. Another focus is reuse of existing technologies that are familiar to embedded developers. So kconfig for the configuration system, which every Linux kernel, not user, but people who have built the kernel will have already used. And GNU Make, which is very popular in the open source world. So these are really the 2 foundational technologies that we use. And this is also important to simply avoid learning things that are too specific to the project. Maybe today we are popular enough that people would accept learning something special. But when you get started as a project, if there's too many things people have to learn to use your project, then it's a real barrier to jumping into the project. So the decision of sticking with those well-known technologies is, I think, important. Another thing that is important is this single tree that we have, very much like the Linux kernel. We have a single tree of source code. So it causes kind of a bottleneck in the sense that all the code has to flow through the same team of people. But the big benefit is that the consistency and the quality is like very, I'm not going to say good, but at least it's pretty well the same across the code base, the logic, the solutions to solve a particular problem. Even in Linux, it has been at times an issue where in one area of the kernel, some issue is solved like this. In another part of the kernel, the exact same problem is solved a completely different way just because people don't realize it's the same problem. Here, the project remains sufficiently small, and all the code being funneled through a small team of people, we, I think, maintain a fairly good consistency on how we approach things.
Yeah, that's
one thing I really like about Buildroot is it's like, it's a simple checkout, and then the number of commands you need to get going is very few. So I think that is definitely a very positive experience for somebody, who is new, maybe coming in, from a different environment. And so that part actually is at least I find that very useful. So moving this, there are now different ecosystems or different infrastructures or frameworks, we can call them, that are out there in open to build systems. There is Linux from scratch, there is Yocto Open Embedded. Then we have Buildroot, and there are a few others, that are around, like NixOS, you name it, right? So what are some of the trade-offs you would think that users have to be aware of, right, when they are building their embedded systems? And, where does, say, people have to go for help or find out saying?
Yeah, so it's a really interesting question, but obviously it depends on what you want to do, right? Depending on what you want to achieve, the answer is going to be completely different. So just taking a few of the ones you named, like Linux from scratch, really interesting project. We talked about like education and digging into things. Linux from scratch is exactly the fit here, but it's more oriented towards building from scratch a desktop-oriented system or a server-oriented system than really an embedded system. But really, if your aim is, I want to build a Linux system, well, the name says it all, from scratch, from the beginning, and learning about every piece and doing it by hand, then Linux from scratch is the way to go. If, however, what you want to build is an embedded product, doing it completely from scratch with no like automation around it is probably going to be a strong limitation at some point. So I would say Linux from scratch from an educational point of view is really awesome. And I believe they have this variant where something called CLFS for a cross-compiled Linux from scratch, where they can teach you how to do the same, but for a different CPU architecture. So that might make a little bit more sense for people working in embedded. But really for doing a final product, I wouldn't really suggest something like that. At the other end of the spectrum, you can use a binary distribution, like you can put Debian, you can put Ubuntu or Fedora on many of the embedded systems. And recently at Bootlin, we've been playing a bit with a tool called Elbe, which is an automation tool to build Debian and Ubuntu images. So it's a little bit like a Deb Bootstrap, but allows you to also compile packages, really generate the complete image in one tool. It's pretty neat, a tool from Linutronics. So it's nice. I mean, you want an Ubuntu system, a Debian system on your target. It's really nice because it really fills the gap between the fact that Ubuntu Debian by history are more like installation oriented. You run an installation wizard, answer a bunch of questions, and then you have a working system. While in the embedded space, we are more like firmware oriented. Usually we have an image where everything is already there, and we just put it on our flash or a storage device, and we turn on the power and everything is ready, which is a little bit different. So Elbe kind of fills that gap and allows to use Debian Ubuntu pretty nicely on embedded systems. But still what you get is a desktop distribution, right? So plenty of dependencies, a relatively heavy system compared to what you could achieve with other solutions. And that's the middle is where things like a Yocto project, Open Embedded, Buildroot, and you say there's a bunch of others like OpenWRT and PTXDist, and lots of people have written their own here, which kind of provides more or less the best of both worlds, of course with some drawbacks, but it gives the best of both worlds in the sense that you have pretty much the same flexibility as with Linux from scratch, because you're building everything from source, so you can tweak the configuration of everything, use whatever compiler version you want to use, apply patches to every piece of software in your system. So you've got like plenty of flexibility, but you don't have this massive hurdle of doing it manually. There's a tool that automates the process of compiling BusyBox and compiling OpenSSL and compiling this and compiling that, knowing about the compatibility issues, all the tricks about cross-compilation that are sometimes a bit difficult. So it brings pretty much the same level of automation and simplicity as using a binary distribution, but while giving you the flexibility of building things from source. So that's how I kind of summarize where Yocto project, Open Embedded, Buildroot, PTXDist all fit. And then when you dive deeper into these type of tools, then of course each has its own strengths and drawbacks. I think as we started touching, Buildroot is kind of on the simplicity side. And it's been, you mentioned how you like Buildroot because it's just like one or two commands and you can build your system. That's absolutely true. But it's been challenging to keep that simplicity while meeting for the increasing requests from users to support more and more complex use cases. So it's been a constant challenge as Buildroot maintainers to keep that balance of remaining simple at first sight while giving enough hooks and mechanisms for more advanced users to do the things that they need to do. And still, even with that, we're not as powerful as Open Embedded can be in many areas. So this is really where one of the differences in the simplicity and learning curve. Buildroot will give you a very easy start and smooth learning curve. Open embedded Yocto will give you a much steeper learning curve, but also the core of the tool is different. Buildroot has a very simple mindset. You define a configuration for a system. You do one build. It builds everything from scratch, produces a firmware image. You put it on your device, and that's it. If you want to do a slightly different system, you have to do another configuration, another complete build that is completely independent from the previous one. Even if they are like 99% the same, still it's two different configurations, two different systems. There's no caching of results between builds. There's no concept of binary packages on the target. It's really just one firmware that you flash. You can't upgrade individual libraries or applications on the target. So at the other end of the spectrum, obviously Open Embedded provides all of that, right? You can, in a much more fine-grained way, describe the different images and machines that you are targeting. So if you have like two slightly different systems, but that share like 99% of the things, it is capable of building only once the common aspects, which is really neat. There's lots of build caching capabilities in Open Embedded, and it has support for package management on the target, which some people like, even though I'm not so sure it's really the killer feature of Open Embedded. I believe the expression of the configuration, the concept of layers, is much more the interesting points of Open Embedded. So yeah, it's two different approaches, and OpenWRT fits a little bit in the middle between the two. It's quite a bit more complex than Buildroot, even though it's some people sometimes mistake it with Buildroot because it was forked from Buildroot like 15-ish years ago, something like this. So it still has a little bit the same look and feel. It uses kconfig, it uses make, but under the hoods, there's nothing common anymore between Buildroot and OpenWRT.
Yeah. And
complexity-wise, they have support for packages on the target, but also their focus is a little bit different, right? Buildroot and Open Embedded, they're completely agnostic build system. They build stuff, and you have to define as a user the image that you want to compose with what you want in it, and do the integration, the polishing between, okay, there is this library that was dropped in my file system and this other library. If they were not meant to work together, then it's up to you to like write an application on top that will do something useful out of it. OpenWRT, they have this principle of out of the box delivering something that looks like a product, which in the case of OpenWRT is a Wi-Fi network router. So it's much more like a market-specific distribution,
right,
than what Buildroot or Open Embedded are really.
Right.
So it's pretty different what they do. Even if you can tweak it to do something else than a Wi-Fi router or networking equipment, but still it's kind of their main goal. And you can do an OpenWRT build, get an image, you put it on your Wi-Fi router, and you have a working Wi-Fi router. I think with Open Embedded or Buildroot, no way you can do that. You would get Linux image with WPA supplicant, hostapd, and IP tables, and lots of tools, but no web interface, no polishing, no integration around. So I think that's another pretty important difference between some of the build systems.
Yeah. I think you really put it in a very nice table, so to speak, to differentiate them. And I think it's very helpful to learn these differences and know where you fit, what you are looking for. And so I think it'll help people get started, in a right fashion, what they're looking for. So, so I'll have like a couple of questions on Buildroot, and then we'll move to others. So on Buildroot, what is like a typical process to say add a package or customize a package, right? And then or kernel, for example, or say I have my own application, right? Then what is kind of my high-level steps? And so if you could kind of like talk to that briefly, that would be very helpful.
So I think really the two levels in terms of Buildroot usage is you're merely a user. So the configuration is based on kconfig. So you make miniconfig and you select all the software elements that you want in your system. You say, I want Qt, I want OpenSSL, and this and that. And you can say, I want this kernel. in this version, and I want to apply those patches, use this device tree. You specify all of this in your configuration. Then you run make, and Buildroot's going to do the downloading and extracting, configuration, building and installation, and generating a file system image for you. So that's really like I would say the first level, like things that already exist in Buildroot are fine for you. The next level where that you ask is like, I want to add a new package. Like there is either an application that I wrote or an open source application or library that is useful and that is not yet in the set of packages known by Buildroot. And in that case, it's relatively easy. We have a pretty extensive reference documentation on how to do that. It's going to be about mainly, on one side, describing options to enable that package, so at least one option to allow the kconfig system to know if the package is enabled or disabled in your particular system. So that's the easy part. And then the more complex part is writing a small makefile that teaches Buildroot on how to retrieve the source code for your package and how to build it. And here, the complexity varies from like a trivial 5-line makefile all the way up to several hundred lines of convoluted makefiles, depending on how complex your application or library is, how well it cross-compiles or not, how many dependencies it has, and things like that. So the complexity can really vary greatly. If it's a simple library that uses the auto tools or CMake or Mason that cross-compiles nicely, doesn't have too much dependency, it's just going to be 5, 10, 15 lines of makefiles and off you go. Of course, if you want to cross-compile, I don't know, Python or Node.js or Chromium or whatnot, it's going to be a completely different story.
Right.
But hopefully for lots of these complex stacks that are very popular, it's already supported in Buildroot, so you don't have to do that work.
Yeah.
And then, so if you want to customize a package, well, you pretty much have to follow the same steps, except that the package already exists. So there's already a set of config options and already a makefile. So you have to understand that makefile and do the adjustments that you need, perhaps because you want to upgrade to a newer version or support a feature that so far was not supported and that you need in your project. And again, I think the complexity can vary greatly between being trivial to being massively complicated, depending on the cases. And what's important, and I think that's the case for a lot of open source projects, but it's true for Buildroot, is that there is a community. There is a very active mailing list, a very active RSC channel. A lot of core contributors are also active on Stack Overflow. So there's lots of ways of getting help. Mm-hmm. So it's pretty common for people to just drop what they've tried to do and say, okay, I've tried to do that, but I'm facing this problem. And for people used to doing Buildroot pretty much all day long, not all the problems, but many problems are fairly common and repeat among packages. So we give some help to a lot of these like new users, new contributors.
Yeah. Yeah. So what are some of your thoughts on like growing the community, like, keeping Buildroot or otherwise any project in mind? Because it's always a challenge, right? You might know that growing a community, it has a certain aspects to it, attracting new users and new developers. So some of the steps that you think or you have already implemented, maybe, if you kind of talk of one or two, that would be really helpful for the community. Yeah.
So to give some numbers, our community, we ship a release every 3 months, and every 3 months we have about 100, 120 contributors. So it's not huge like the Linux kernel, but it's not like a project maintained with just 2-3 people, right? It's a project that receives a contribution from a decent contributor base. Mm-hmm. I think, I don't know if we're really the best at that, but you need to obviously be welcoming to newcomers. So as a maintainer, I have a very different way of reviewing and responding to contributions depending on who is making the contribution. So I will have a much higher requirements from a seasoned, regular, senior contributor from whom I will expect like a lot of things to be like good or perfect from the start. While for a newcomer, I will pretty much like ignore all the mistakes and instead like teach about the mistakes.
Yeah.
And we've seen in many cases that Buildroot is very often for many of our contributors the first open source contribution they make. We see that by their way of interacting and their struggle with the tools and things like that. But yeah, this is to me the first thing that I do is adapt the way I react to code being posted to who is posting it. And that I believe is really important on some, I'm sometimes having never harsh words, but pretty direct words on code that isn't great or insufficiently tested from like regular contributors, while code that is in fact much more awful coming from new contributors will receive a really warm welcome, like, hey, it's great, your first contribution, that's good, but there's a few things that you need to adjust. And then when in the explanation, it's not going to be like just like one or two words things that say fix it up, but more like what the why and the reasons, and give more background in the hope that those people will stick around, which does work. I mean, it's of course there's a lot of drive-by contributions, and you see one or two patches, and then the person goes away. But there's also a few of those people who like do one, and then two, and then 5 contributions, and then 10, and then they become regular contributors. Right. So I think that's one important thing that can be done. Of course, you need to do a bit of marketing. Well, marketing in the open source sense of it, of course, giving talks is one way of like raising awareness about your project, what's changing, who is using it, that kind of things. We could probably do better. I mean, I believe very few people know that Tesla and SpaceX are using Buildroot, and Google is using Buildroot, that kind of big companies. We mention it from time to time, but we're not, I think compared to what it means in terms of like image, we're not making a lot of fuss about it. We could perhaps do more. But yeah, doing some talks to raise awareness about your project. But then I think the main marketing is really the people using your project, right? If they find it good, then the word will spread. They will write blog posts, they will write articles in magazines, they will do that kind of things. And that is how really I think Buildroot has grown. Funnily enough, there's been a discussion that reflects a discussion in the kernel community about contribution tooling in recent times in the Buildroot community around email-based contribution, which we are still using. Good old guys. And there's a push from I'm not sure if it's a younger generation or different culture to like GitLab, GitHub-based pull request, merge request, which is the exact same like debate that is animating the kernel community these days, and probably a number of other like old-fashioned open source communities. So we had this debate like just like this month and last month. I think it's still a pretty warm debate. And it's interesting to see the conflict between like those old timers that have their habits of, and I'm among them, of course, right? Their habits of tools, email based, and these command line tools and so on, and this newer generation want web based interfaces who only use webmails, so they get a bit disconnected from I believe the power of real email clients, and then there's this disconnect that is a bit going on in many open source communities. I mean, in the newer ones, it's usually easier, right? They start right away from GitHub, so it's kind of from day one they're using this model. But for those other communities, Buildroot has been around since 2001. So back then, GitHub was not even a thing. Git was not even a thing. So we have to go through that. Maybe through that change, but it's much more difficult than for these newer projects.
Yeah, that's actually a very good point. And you're right, like a lot of communities are having similar debates, how should we make our contribution process a little more modern, or a little more appealing to modern tools. And I've seen the same debate in LLVM community, in open embedded community, and also, Buildroot. So that's probably a healthy debate, I think, in there.
Yeah, it is. I always feel a little bit weird about that debate because people are saying it's too complex to send patches over email. But I like for the kernel, I mean, what is more complex, write kernel code or send an email? I mean, I believe writing kernel code is probably like a few orders of magnitude more difficult than setting up Git send email and that sort of tooling, right? So some people say I think to send patches over email is a barrier to entry into projects because it's too complex. But I find that argument a bit odd, right? Because the complexity of even Buildroot, it's a lot simpler than doing kernel work by far and large. But still, it's much more complicated to dive into a code base than having to set up Git and email. So it's always been a funny argument, and I believe it's really more it's not really that those old timers are against welcoming new contributors. It's really a tool culture difference, right? Being used to webmails and web-based tools and so on.
Correct.
Compared to these older people who have been using like email-based clients for decades and different way of tooling, I guess.
Yeah. So I think you've been doing a lot of trainings as part of your job. So and Cliff and I, we looked through several times through, various trainings that we have posted, and they are very detailed and full of like a lot of good content. And so we have always wondered, like, what goes behind them and how you go about doing those. And I know that, you've been also involved in Embedded Linux Conference for a long time. And so if you could talk about that and, because it goes probably hand in hand in terms of trainings and, what was your, because I know that you did videos before Linux Foundation did videos. So if you talk about that a little bit from like educating and training point of view, that would be very good.
Sure. So a lot of that is because of Free Electrons founder Michael Optenacker. So he's a guy from the open source community. I had the chance to meet him in like 2004, 5, 6, 7, around those years. Back then I was like at the end of my university, beginning of my professional career. And Michael started Free Electrons back then in 2004. So really the time he started that company. And on my side, I was already doing a lot of this knowledge sharing. I said writing those articles, but I also did things that I find completely crazy today. Back when I was a student in university, I gave like day-long talks on how an operating system is working. When I went to a free software conference in France, I would submit talks. So already back then I was in university giving talks like half day long. So it was almost like a course more than a talk. And that's how I ended up meeting Michael Optenacker, who saw that I was I knew some stuff at the technical level, but I was also very interested in sharing it with others and explaining it with others. And I remember giving some of those day-long courses without any materials, like just a whiteboard and a pen, and that was all I had to talk about operating system for an entire day. Doing trainings, sharing technical things that I know has always been something I was really enjoying to do. And so when Michael asked me if I was interested in joining Free Electrons, it was the first employee he hired. I was really happy. It gave me the chance of leaving a closed source company to a company with a radically different mindset, right? Michael's mindset is fully towards open source and contributing and I'm not going to say business is secondary because it was also meant to be a business where we can pay our houses and food and stuff, but it's open source and contribution and knowledge sharing has always been a key driver. So that's one of the reasons why Michael has been sharing the training materials under a Creative Commons license since the very beginning. So it's been like more than 15 years now. We've never changed that. We do a training It's all online, so now it's on GitHub because GitHub not exists. So all the source code is on GitHub. Everybody can see it, can use it. We have competitors we know who use them, but yeah, we're fine with that. I mean, it just spreads the knowledge. Mm-hmm. So it's been like a very strong value for electrons no bootling, and we've never changed our mind about it. I think last year we released a new course on Linux graphics, like all these graphic stack in Linux, like GRM, OpenGL, and stuff. And from the very course we gave to the first customer, everything was online, Creative Commons. Mm-hmm. So yeah, we really believe in these values. Of course, they also give an interesting business advantage, right? In terms of marketing, we don't do any marketing as a company. Our training materials, the fact that a lot of people know about them and use them without ever like buying services from us, is a very strong way of spreading our name and brand and expertise in different companies, and that has been pretty successful so far. And yeah, that's still something we're doing, sharing these training materials openly. And so we maintain them I'm not going to say on a daily basis, but Michael is still very active in doing the kind of this day-to-day maintenance, upgrading like the kernel that we're using, the U-boot we're using, all these like small improvements here and there that are really important to keep information accurate. And then from time to time, we do bigger efforts of like really reworking completely a course or a part of a course or developing a completely new course. So there's sometimes these bigger chunks of work, but there's also this like day-to-day maintenance, very much like a code base, right? Sometimes you just add a few features here and there, address a few bugs, and other times you do more major refactoring. So we pretty much handle it the same way.
Yeah. So that's like keeping it more pertaining and more up to date, and that requires a bit of effort all the time.
Yeah. And then I think the analogy with software is really relevant, because whenever I teach one of our courses, the fact of teaching it gives me idea about how to improve it. So there's this constant, same snowball effects that I was referring to earlier, right? You get feedback from the people, you see how they react to how you're explaining something. You realize, oh, maybe I should add this other explanation or do the diagram differently because it would help this or that concept to be more easily understood by the audience. And again, that's this constant feedback that drives how we try to improve the training materials. We could do better with more time, but yeah, at least we're already spending a good amount of time maintaining them. And so indeed, ELC is so the Embedded Linux conference it's the go-to conference for people in our field, right? It's you have to be there. I think it's next to the open training materials, ELC has been for Free Electrons No Bootling the second main driver for business, right? For meeting people, for getting the brand known, for showing the expertise and so on. And so I got hired in January 2008 by Michael. Attended my first ELC just a few months later in April 2008. It wasn't my first international conference. At my previous job, I had the chance of attending the Ottawa Linux Symposium, an excellent conference back in the days. So going international and attending those events was not new for me, but it was new for Embedded. And that was like amazing. I do remember those first ELC was it was spring one, so in the US, which was, again, for a person relatively young in his career, a great opportunity. And all the talks were like, it's been like, all this information, all those things that I don't know, all those things that I need to learn, that I need to understand more, is like, really a feeling that was so great. And since then, I haven't missed a single ELC or ELCE, I believe. So it's been like every 6 months, this tradition of going to ELC, ELCE. My perspective has changed a bit over the conference. I believe there's been changes on my side, I guess, an increase in expertise. So at the time where everything sounded new and exciting and amazing, now sounds a little bit like, yeah, it's been the same thing, like as usual. I already know about this topic, so I just learn a few more things. But there's always new things, new fields, new topics. But in some areas, it's a little bit like always the same.
Yeah. So it was more like you were in the taking mode, and now you're in the giving mode, right?
Yeah. There's probably of that. I know that the part that I enjoyed the most at ELC is more like meeting the people, reconnecting with the folks that I know. More like a big family, but it's not so big. This family of embedded Linux developers around the world who get to meet every 6 months, and no longer because of the health situation right now. And it's a pity. And I guess also another thing that perhaps changed a bit the conference is it really changed from this like not really hobbyist but technical people driven conference to a more like corporate, a little bit more marketing oriented conference. It's still very technical. This part is okay, but still the look and feel is it's very different. I remember about my first ELC. I have some very good memories of it. So it took place in Mountain View in California. I think it was in the Computer History Museum in Mountain View, so just a few blocks away from Google. And the social event was a laser game, Laser Quest. So I remember it was my first ELC, and I could shoot Tim Bird in the laser game. It was really awesome. So nowadays, when you go to the social event, it's like a cocktail, with sponsors being thanked and all.
Yeah.
Back then, you would just kick the ass of the other embedded Linux developers.
Yeah. Yeah, indeed. Yeah. So I think, we have a few questions, Cliff, for Thomas. And I think one thing that we always find interesting is that you have like this small knit team of very handful of high, developers, which basically, you are very visible in the community. And, and if you look at the, top 10 contributors or, top 20 contributors of Linux kernel, then your name appears there, as a company as well. So we always were curious, like, for people who have like small companies or, who are maybe individual contributors and they are listening to this, what does it take to build this, a highly efficient small team?
That's a very interesting question. I did cover that quite a bit in a keynote in ELCE Dublin. I don't know if you remember that one. It was the most intimidating experience of my life, right? I was speaking, I think, right after Linus Torvalds or right before, I don't remember. Well, that was intimidating. And precisely the question I was asked to answer in the keynote, or try to ask, was how did we manage with like, I think at the time was like 6 or 8 people, end up like being in the top 10, top 15 contributors to the Linux kernel. So I think the root values of free electrons and Bootlin really help here. This focus of doing open source and upstream has been driving the contracts that we had chosen. That was an important thing because, if you take just what comes, because it, brings more money or something like that for us, the amount of contribution you can extract from a project has been, and when I say extract, it sounds maybe a bit negative, but it's not at all. The more contributions you can do based on a project is what has been the driving factor to decide which project we would take from the different customers we had. So that's one first key to that, and also to be really committed to doing those contributions. So in some projects, it was really the goal. Like we had contracts with silicon vendors where the goal was really to have the code upstream. So these are obviously the best projects because you're really paid to do that work that you like. But we also have other more regular board support package projects where the customer wants a kernel that runs on his hardware, and whether it goes upstream or not is maybe good, but it's not such a big deal if it remains a stack of patches. But it's really on our side that we say, no, this is something we want to push upstream because we believe this is the right thing to do, because we like to do it, and because we also think it's the third way of getting more business next to the open training materials and giving talks, is showing that you contribute, show your expertise, so that the business card that we have is you go to git.kane.org, you search for brooklyn.can contributions, and here you see what we're capable of doing. We don't have to spend like hours convincing that we have the right expertise. The expertise is just here, right in front of your eyes. See the patches, see the drivers we've written, see the complexity of the code that we've worked on, and just judge by yourself. So it's been important for us. And then the next, so those are more related to like the philosophy and the core values which Michael had at the beginning, which I was fully sharing, of course. And Michael has always been like, yeah, if we need to spend 2 more days on doing that, pushing it upstream, we're going to spend those 2 more days. From a business point of view, in the short term, it doesn't make any sense, right? Mm-hmm. But in the more like long term of things, it does make sense to do that, even for us in terms of image, reputation, and so on. And the second aspect is just the people, right? Yeah. If you have the right people in your team, none of what we have done would have been possible without the engineers who really like what they are doing. They like sending patches. They like this, exactly what we've seen before, like this rewarding feeling of sending patches, getting like top level maintainers, giving them feedback, seeing that feedback improve over time as they progress through in their expertise in terms of kernel contribution. All this is, it was really, really important. So indeed, we could do that also because, we're just like 6, 7, 8 engineers, but all of us were people who really believed in open source, and we still do, and wanted things to go upstream, and were really motivated by that. There are sometimes engineers who they like to solve technical problems and complex ones, but the aspect of sharing and getting the code upstream, cleaning up is not something they really like, and it's okay. Everybody can have different tastes and so on. But at Brooklyn, we have always tried to have a good balance between people who like the technical aspects, but also who like this the social aspect that is implied by participating to a community, who like this rewarding aspect of the of seeing its contributions go into the official Linux kernel, then giving a talk about these contributions and things like that. So really, both the management point of view and the engineer's point of view has been important. And then the third aspect is, of course, the customers, right? Because we've been able to find the right customers, wanted to do the right thing at the right time, has been really key into pushing us in that direction.
Nice. Yeah, so I think something that, this is many times you go through your career and different experiences, and you find that, you build your opinions or informed opinion that is not quite, with the rest of the team, but, in general, it is more an unpopular opinion, right? So anything that, you would advise people not to do?
Not to do. Well, I remember that was on the list of topics. So I don't know if I have a lot of unpopular opinions. Perhaps the one thing that I find weird is at the technical level is how many people get into embedded Linux through the Raspberry Pi ecosystem. And it's great. I mean, Raspberry Pi has done tons of excellent things, has dropped the cost of things, and has dropped the entry barrier to embedded a lot, and has allowed makers and universities to do tons of things. So lots of things are great in Raspberry Pi, but also they've also decided to do those great things a little bit, more than a little bit outside of the standard path that the open source community has been designing, that by remaining like a vendor specific kernel on their side, by having no proper bootloader, by having So those
graphic
people who
system.
then end up learning embedded Linux through Raspberry Pi, they don't learn that much embedded Linux in the end. They learn like the Raspberry Pi ecosystem. And then when they switch to everything else, they find it awkward. But really, it's the other way around, right? It's every other platform as a U-boot, as an upstream kernel, and then it's pretty much the same. And sometimes it's less different when you switch from, I don't know, an ARM platform to a MIP platform than when you switch to an ARM platform to the Raspberry Pi, right? Because so maybe, I don't know, maybe it's an unpopular opinion, but I would have liked them to be more standard in how they support their platform. I think it's a path they're taking, right? By having more support in the upstream kernel, by having support in upstream Mesa 3D for the OpenGL acceleration, and lots of different things. So it is coming, but I believe it's been a bit long to come. It's also maybe difficult for people doing marketing. People who want to do marketing, they want to show differentiators. Yeah. But at our level of the stack, differentiation is annoying. What you want is boring. It's like standardization, follow the same APIs, the same, I'm sure you've been working on networking equipment, and networking is another field where every company is inventing its own stack to manage, I don't know, switches and whatnot. And so it's a nightmare for people buying those chips to fiddle with all those custom SDKs and things. Yep. But selling the fact that, but there are standard APIs in Linux to do that. And if they are not like complete enough, we can also extend them, but at least it's going to be the same foundation for everybody to use. Yeah, but then what is our differentiation? Well, your differentiation is that you're not different, so you're good. So that may be an unpopular opinion. I don't know if that finds
that's a good one.
Yeah, I agree. Yeah.
Good. So I think we basically any final bit of advice that you would offer to from your experiences, or any books or any podcasts or blogs that you read and that are useful for folks, any movies, your hobbies, that you find interesting, anything.
I think my word of advice kind of reflects back to the very beginning of our discussion. Find a goal and stay focused. Find something that you want to learn. In my case, it was writing an operating system. Was completely useless, but that didn't matter. All right, it was a learning experience, but by sticking to it, that's what allowed me to grow. And it's a little bit the same today. Find a piece of hardware that doesn't have support, or that doesn't have support in upstream Linux. Develop the support for it, or clean it up, push it upstream. Find the goal. I see so many people wanting to learn like kernel development, but not knowing what to do. And on the other end, I can see from my embedded experience the amount of work that needs to be done in terms of hardware support, which is really massive. So find something that makes sense. Just don't learn like kernel development for the sake of learning kernel development. Learn it to solve a specific problem that is affecting you. And that is something you can find by, if you're interested in embedded, of course, is buying some embedded boards, testing things, trying things out, and then finding something that is missing or that could be better, and push that, and stay focused on that. I think that's the word of advice I would have.
Thanks, Thomas. So the final word's really interesting. Find something that solves a problem. And thank you, Thomas, for being with us today on this podcast. I think it has a lot of good information and experience that I think everybody will benefit from us. So Cliff, what's your thoughts?
Yes, likewise, it's been a pleasure to listen and learn, and we definitely a lot to process here, so we appreciate your time.
Well, thanks a lot for having me as a guest, and hope to see you in the future in real life.
Yes.
Here. Thank you, Thomas.
Thank you. Bye-bye.
Bye-bye.
Okay.
Bye-bye. Thank you.